Hey everybody, it's Mr. Carr again. Today we're going to start Unit 5. We're looking at 5.1, Day 1. The goal today is to looking at function operations and compositions. So when we look at our functions, we're going to be doing a lot with our function notation. Remember, this means f of x, g of x. These are functions instead of just x and y. So we can actually add, subtract, multiply, or divide our functions. So in our first case here, we're looking at f of x plus g of x. So we're just going to add those together. So f of x, whoops, take care of that. F of x plus g of x is just going to equal to 4x plus 3 plus a negative 9x plus 5. So that means all we're looking for is our like terms. We take 4x and negative 9x, those can go together. So that becomes a negative 5x. And then 3 and positive 5 become a positive 8. So that means f of x plus g of x here equals negative 5x plus 8. Now, when I do my subtraction, same idea, but we have to be very careful when we do our subtractions because this f of x minus g of x is going to be taking our f of x function, which is 4x plus 3, and we're going to subtract. I'm going to put in parentheses. We're subtracting the entire thing, negative 9x plus 5. Okay. So when I subtract that, it's important to use the parentheses there because I'm subtracting everything, meaning this is going to be a negative of negative 9x and a negative of 5. So that means f of x minus g of x. If I rewrite it all, it's going to be 4x plus 3 plus 9x minus 5. Now we just put our like terms together so that f of x minus g of x equals 4x plus 9x is a 13x. And then 3 minus 5 is a negative 2. So you can see the differences when we add or subtract our functions here. Okay. We can also do multiplication division. So when we do multiplication, again, we're just doing this right here. We're just multiplying those two together. So when I look at f of x times g of x, that's going to equal to a 4x plus 3 times a negative 9x plus 5. So that means we're just going to do our distribution property here. So 4x is going to multiply to both of those items. So we're going to have f of x times g of x. It's going to equal to negative 36x squared plus 20x. 3 times negative 9 is a negative 27x. 3 times 5 is a positive 15. And like before, I'm going to combine my like terms. So that's these two. So it's a negative 36x squared. 20 minus 27 is a negative 7x, and then plus 15. So that's our new function, which is just the quadratic. Division, make sure you do the first one divided by the second one. To show division, the easiest way to do it is with fractions. So that means f of x divided by g of x is going to be equal to 4x plus 3 over negative 9x plus 5. Now, that's it. There's nothing else to do. I'm not going to go through and actually divide this out. I am going to do a quick analysis. If you remember from before, with our rational functions, because that's what I've created with our composite, our composite, with our function operation here, the denominator cannot equal 0. So because that cannot equal 0, I'm going to find out when does not negative 9x plus 5 equal to 0. So that means negative 9x equals a negative 5 when I subtract that over. Dividing by negative 9, x equals a positive 5/9. So this is my new function, but also x cannot equal to 5/9. It's important to recognize that just because we are restricting our domain when we go through and do our division now. Okay. So the next one is a function composition. Okay. Function composition is an operation in which you plug the answer from one function into another function, or plug an entire function into another function. So we can think of it as like a substitution from back in when we did our substitution elimination days. When we read this, f like this, it's f of g of x. Okay. You're also going to see it like this. This is the same as doing f like a little circle like that. These two mean the same thing. It's f of g of x. So what that means is my g of x is my input. Okay. I'm going to input that entire function into f of x or some kind of value. So in this case, that's what I'm going to do here. I'm going to go ahead and just plug my entire function into another one. So when I do f of g of x here, this is my input. So that's going to go inside this one for the first part. So f of g of x, like that. Okay. When I do this, I like to do it where I start with my f of x function, and I'm just going to replace the x with a parentheses. So this is what it is. It's 4x squared. Technically, it's 4x squared. But now what goes inside is g of x. This is going to go inside here. So I'm going to go ahead and put 5x minus 2. From here, we're going to go ahead and distribute and simplify. So when I do that, make sure you are distributing the 5x minus 2. Yeah, I'll just do it right over here. So 5x minus 2 times 5x minus 2. That distributes there. So I'm going to have f of g of x is equal to 4 times, that's going to be 25x squared minus 10. So it'll be, let's see here, already here, 25x squared minus 10x minus 10x plus 4. So that'll be minus 20x plus 4. And then finally, I'll distribute the 4. So f of g of x is equal to 100x squared minus 80x plus 16. Okay. Doing something very similar with my... Here, let's do this. I'm going to make a little bit more space by just bringing this over here a little closer. Okay. So now, when I do f of x, f of x, okay? So I'm just going to take this function and plug it in itself. So I'm going to start the same way. I'm going to do 4 times something squared. Well, since f of x is my input function, I'm just going to take the 4x squared and plug it in there. So when I do this, I'm going to go ahead and use my properties and simplify this a little bit. So 4x squared to the second power, that's going to become 4 to the second power is 16. X squared to the second power is x to the fourth. From here, I could just multiply 4 times 16. So that f of x is equal to 64 x to the fourth power. I've got parentheses there. Okay. So one more example of this. Sometimes we can evaluate using our composition by plugging an answer from one function into another. So when I say f of g of 3, I could go through and do like we just did. We take our whole g of x function and plug it inside here. So it's going to look like that. Sometimes that gets a little complicated, especially with x squareds. Instead of having to go through and distribute that, we can just do this. Let's evaluate g of 3. So that is going to go into here. So that's going to be 3 squared plus 4. And so that means g of 3 is equal to 9 plus 4, which is equal to 13. My output for my g of 3 function is now going to be my input for the f function. So I'm going to use the 13. I'm going to find f of 13. That's all it is. It's just going to be like a chain. So f of 13 is equal to 2 times 13 minus 7. So that's 26 minus 7. And f of 13 is equal to 19. So that's my answer for f of g of... So f of g of 3 equals 19. Okay. We're going to do the same thing with the other one. We're just going to go the other direction with it. So I'm going to first evaluate f of 3. So that's equal to 2 times 3 minus 7. Oops. So that means f of 3 is equal to 6 minus 7, which is equal to a negative 1. Now that I have that, I'm going to plug that into the g function. So g of negative 1 equals negative 1 squared plus 4. G of negative 1 is equal to 1 plus 4, which just equals 5. So that means my final answer here is g of f of 3 just equals 5. Okay, so we get 19 and 5 in these two cases. So look at, you notice how the order matters. If I do the g function first, then the f function, they get two different answers versus f and then g. Okay, and that's it for day 1. So we're just looking at our operations, dealing with adding, subtracting, multiplying, dividing, as well as these composition functions. So that means we're plugging a function into another one. All right, and that's it for today. Take care, everyone.